Good evening. I'd like to welcome everybody to class tonight. Last week, we started to take a look at our second argument for God's existence, or the second reason to believe that God exists. And we made it through the first premise of the argument, and the goal today is to finish it. We're going to look at the defense of the second premise, and we will finish off the cosmological argument. Before we get into our review, Jason Brown's going to lead us in a word of prayer.
Let's bow. Our dear Holy Heavenly Father, we thank you for this beautiful, great day that you have given us to be here at this building. We pray that you be with Brother Kevin as he gets ready to give us this study. We pray that you be with him as he studied this. We pray that you would forgive us of our many sins, dear Father. We pray all of these things in your Son's precious name.
Amen.
Amen.
Thanks, Jason. All right, let's begin as always with reciting 1 Peter 3:15 together. But sanctify Christ as Lord in your hearts, always being ready to make a defense to everyone who asks you to give an account for the hope that is in you, yet with gentleness and reverence. Good. The first argument that we looked at for God's existence was called the contingency argument. And can somebody tell me, what is the one-sentence summary of the contingency argument? Selena?
God is the best explanation for the beginning of the universe.
Ooh, you are close. I will give you credit for the answer to the next argument. The one-sentence summary of the next argument is, as Selena said, God is the best explanation for the beginning of the universe. Can somebody tell me what is the one-sentence summary for the contingency argument, William?
God is the best explanation for it.
That's how the phrase starts. How does it end for the contingency argument?
Existence?
Yeah, there you go. God is the best explanation for the existence of the universe. The contingency argument says that we observe that the universe exists, and the best explanation for that is that God made it. It's the only explanation that's offered. We also, last week, took a look at how logic works, and we said that this format, when a argument is formatted like this, it's called a syllogism. Can somebody tell me, what are steps 1 and 2 called of this syllogism? Logan?
If I do the explanation like that, if P is Q, therefore then Q, therefore P.
That's right. Can somebody help them out? What are lines 1 and 2 called in this argument? Connor?
Oh, premise.
Yeah, those are called premises. Very good. And what is step 3 called? Yes, Logan? Thesis is not the term that... Conclusion, there you go. So line 3 is called the conclusion. And what is the term that we use to describe an argument that follows one of the 9 rules of logic? What is the term that we use to describe an argument that follows one of the 9 rules of logic? Mason?
P and Q.
No, not P and Q. William? I'm going to have to move on, buddy. Gabby, do you know it? Very good. Logically valid. If an argument follows one of the 9 rules of logic, that makes it logically valid. Can somebody tell me, what is the significance of a logically valid argument? Logan?
The truth of the conclusion flows necessarily from the truth of the premise.
Yeah, very good. If the premises are true, then the conclusion is necessarily true. So if the skeptic wants to deny the conclusion, what is he going to have to do? William? Yes, if the skeptic wants to deny the conclusion of a logically valid argument, what's he going to have to do? Very good. Deny one of the premises. And we saw last week that no premise can be 100% true unless it's true by definition. And so the skeptic can deny any premise that he wants to as long as he's willing to pay the price. What is the price of denying a premise with a high degree of probability? Mason? You have to be ready to answer. That is on the right track, but not the idea I'm looking for. What's the price of denying a premise that is very likely to be true? Yes, Logan?
You have to be ready to risk the appearance of irrationality or craziness.
Yeah, so the price would be the appearance of irrationality. If you denied something that's very probably true, it makes you look irrational. It makes you look crazy to others. So what can we do to raise the price of denying a premise? Yes, Gabby?
Make the premise even more undeniable.
Yeah, very good. We can make the premise even more undeniable by doing what? Showing that it's true. I'll take that. By offering evidence. When we offer evidence for a premise, it makes it more certainly true. And the higher the certainty that it's true, the higher the price it is to deny it. The crazier it looks to deny a premise. Okay, so that's how logic works. Any questions on logic before we move on to the cosmological argument? Okay, good. Can somebody tell me, actually, Selena already answered this question. The one-sentence summary of the cosmological argument is, God is the best explanation for the beginning of the universe. So the one-sentence summary of the contingency argument is God is the best explanation for the existence of the universe. That of the cosmological argument is God is the best explanation for the beginning of the universe. And the syllogism for the cosmological argument looks like this. 1, whatever begins to exist has a cause. 2, the universe began to exist. Oops, I was going to ask that as a question. Can somebody tell me what is the conclusion to this argument? Selena? Very good. Therefore, the universe has a cause. And we asked last week, if the conclusion just says that the universe has a cause, how is this an argument for God's existence? And we saw that just by looking at what the universe consists of, we can draw out the attributes of the cause of the universe. We saw last week that the universe consists of matter, space, and time. Because the cause of the universe brought all matter into existence, that makes it what? Mason? Yeah, immaterial is correct. Hold on to the rest of those answers, because I haven't asked that question yet. Because the cause brought all space into existence, that makes it what? Logan? Spaceless, correct. And because the cause brought all of time into existence, that makes it what, William? Timeless, good. So already we can tell that the universe is immaterial, spaceless, and timeless. Because the cause had the ability to bring all of matter, space, and time into existence, that makes it what? Selena? Unimaginably powerful is correct. And then we also saw last week that for a timeless cause to produce a temporal effect, there must have been an act of free will. So the cause of the universe is also personal. It's a person. It's someone with a mind and a will, and not just an impersonal force. So by looking at the universe alone, we can tell that the cause of the universe must be an immaterial, spaceless, timeless, unimaginably powerful, personal creator of the universe. And what do we call that? God. So if the universe has a cause, that cause is God. Now, because this is a logically valid argument, if the atheist wants to deny the conclusion, what is he going to have to do? Very good, Kelly. He's going to have to deny either premise 1 or premise 2. And when last week we took a look at premise 1, whatever begins to exist has a cause. And whenever you deny a statement, you're making a statement of your own. What statement would the atheist be making if he says that premise 1 is false? If he says that it's not true, that whatever begins to exist has a cause, what is he saying is true? Logan, you know it? Sure. So if the atheist says that it's not true, that whatever begins to exist has a cause, what is he saying is true? Yeah, Logan?
That anything can just create whatever it wants.
That anything...
It can just be created, and that everything, that something can
there you go. Yeah, he said that something can come from nothing. To deny premise 1 is to say that some things can come into existence without a cause. And we saw last week that we really shouldn't even have to defend premise 1 because premise 1 is just a restatement of what natural law? Do you guys remember? Mason, do you not? Okay. Logan? Yeah, that's the idea. What was the name of the natural law that premise 1 is a restatement of? It is the law of, Mason? You're close. It is the law of causality. The law of causality, which says that every beginning or change of existence has a cause. And the law of causality is the foundation of all science. If the law of causality wasn't true, if it didn't always hold true, then there would be no science. So to deny premise 1 is to deny the very foundation of science. So it can't be sincerely denied by any sincere seeker of truth. But we saw that because the evidence for premise 2, the beginning of the universe, has become so strong lately, atheists have begun denying premise 1 and saying that some things can come from nothing. And so we looked at 2 lines of evidence to show that that's not true, to show that it is true that everything that begins to exist has a cause. Does anybody remember what was the first line of evidence that we looked at? Connor? You guys have got to have the answer before you raise your hand, okay? Selena, do you know what it is? Yeah, very good. Something cannot come from nothing. To say that something can come from nothing is literally worse than magic. When a magician pulls a rabbit out of a hat, at least you have the magician, not to mention the hat. But to say that the universe came into being out of nothing, they're saying it came out of being out of literally not anything at all, which we all know is impossible. We looked at the possible objection of quantum physics, and we saw why that wasn't the case. Can anybody tell me what was the second line of evidence that we used to show that premise 1 was true? William? You got to have the answer before you raise your hand, buddy. Okay.
If something can come into being from nothing, then it becomes
Inexplicable.
inexplicable. Why does anything or everything doesn't come into being from nothing?
Yeah, you got it. If something can come into being from nothing, then it becomes inexplicable why just anything or everything doesn't come into existence from nothing. If nothingness can allow the universe to pop into existence, what stops it from allowing everything to pop into existence, like bicycles, people, cities, horses, or Mountain Dew? If the universe could pop into existence out of nothing, we would see anything and everything popping in and out of existence all of the time, and yet we don't. So it's good evidence that nothing can pop into existence out of nothing. All right, so we've seen that premise 1 is true to a very high degree of probability, and so it hardly needs defending. The price of denying premise 1 is to deny the very foundation of science and show yourself to be someone who isn't sincerely interested in truth. And so the truth of the whole argument really just rests on the shoulders of premise 2. The universe began to exist. This is the more controversial premise of the argument. Can somebody tell me, if the atheist wanted to deny premise 2, what statement of his own would he be making? If the atheist says that that it's not true that the universe began to exist, what is he saying is true? Mason?
That the universe, need my pencil back.
Sure, you can look at your notes. It's not in your notes, though. Gabby? Very good. Yeah, that the universe always existed. They're saying that the universe has existed eternally. Another way of saying this is to say that there are an infinite number of past events. That word events is just a generic word for any length of time. So it could be days or hours or minutes or seconds. That word events is just a generic word for any length of time. And so in this class, you'll probably hear me flip back and forth between the word events and the word days. Really, I'm just talking about any increment of past time. The atheist is saying that the universe has an infinite number of days in its past, or an infinite number of seconds in its past. So the question becomes, is it more rational to think that the past is finite, or that the past is infinite? We're going to look at 4 lines of evidence for the beginning of the universe. 2 are going to come from philosophy, and 2 are going to come from science. And if you were going to, yes, Brian?
Just a quick question. If they say the universe has always existed, have they given up on the Big Bang idea?
That is an excellent question, and I'm going to have you save that one for our fourth line of evidence, because you're right, the Big Bang does show that the universe has a beginning, right? Good. Yes, Selena?
I always thought that God created himself. Is that kind of true?
No, God did not create himself. God is not a created being. Rather, God is the base reality. He has always existed. He was not created, and he does not have a cause. So there's going to be 4 lines of evidence that we're going to look at, 2 philosophical lines and 2 scientific lines. And if you were to ask me the relationship between these 2 types of evidence, I would say that the philosophical evidence is the more solid. And that's because scientific evidence is always provisional. Scientific evidence is always subject to change. And scientific conclusions often do change with the advancement of science. So really, the scientific evidence just serves to confirm what we already know through philosophy. And any one of these 4 lines of evidence is going to make it more probable than not that premise 2 is true. And so you can imagine these 4 lines of evidence as 4 pillars that support the truth of premise 2, any one of which has the strength to keep premise 2 aloft. So the fact that we have 4 lines of evidence makes the case all the more powerful, that it's true that the universe began to exist. The first line of evidence that we're going to look at is the idea that an actually infinite number of things cannot exist. An actually infinite number of things cannot exist. If you're following along on the handout, I'm going to go away from this slide for now, but we're going to come back to it each time we introduce a new line of evidence. So don't worry, I'm not skipping anything on you. An actually infinite number of things cannot exist. We all recognize that some things are potentially infinite. For example, if you took any finite length, you could potentially infinitely divide that length in half. So let's say you had a foot. You could divide it in half down to 6 inches, and then down to 3 inches, and then down to 1.5 inches, and then down to 3/4 of an inch, on and on and on and on. It's potentially infinite. Or here's another example. Has anybody ever taken a calculator that looks like this one and typed 1 + 1 and then hit the equals button, and then found out that every time you hit the equals button, it gives you another number, 1 higher, so you can go 2, 3, 4, 5, 6, 7, 8. I did this when I was a kid, and William and Selena do this, and it makes me happy. If calculator memory was not a problem, you could potentially infinitely push that equals button, and it would always return a new result, right? You'd always get 1 number higher than the number before. Yes, Gabby? The digits of pi are infinite. Very good. Or potentially infinite. Good. But the question is, could there ever actually be an actual infinity? Take that ruler, for example. If you were dividing that ruler in half over and over and over again, would you ever reach an infinitieth division? No, right? It's potentially infinite. It will go on and forever, and infinity isn't a number that you could eventually reach, right? How about that calculator? If you keep hitting equals on that calculator, will it eventually tell you that you've reached infinity? No, infinity is not a number. It's just a potential limit, and in this case, it's unlimited. Yes, Ed?
Just a quick comment on those kind of issues. Science approximates what we observe in the world. isn't a guarantee that whatever we can measure or whatever we can propose on a calculator fits the world the way the world.
Yeah, we're going to get that in just a second. So you can never reach an infinitieth division, and that calculator is never going to tell you that you've reached infinity. Nothing can be actually infinite. The actual infinite doesn't exist in the real world. And so you would think, and so what that means is could there be an actually infinite number of days in our past? No, there's no such thing as an actual infinity. Could you mark a calendar for every past day if there were an infinite number of days? No, there's no such thing. And you would think that this is where this line of evidence ends. It's impossible to have an actual infinity. Case closed. But we can leave it to the mathematicians to make things harder than they have to be. Because in mathematics, there is such a thing as an actual infinity. In set theory, there is such a thing as an actual infinity, and it's useful for solving equations. See, in mathematics, there's two types of infinity. The first type of infinity is the one that we just talked about, the potential infinity, the one with the dividing the ruler in half in the calculator. And this type of infinity is symbolized by this symbol right here, which is called the lemniscate, or the lazy 8. And this type of infinity is not a number. It's just a limit, or it means unlimited. And it's used in calculus. In fact, the only thing I remember from my high school calculus class is the phrase, as x approaches infinity. It's used a lot. And then there's this type of infinity. This is actually infinity, and it is symbolized by the Hebrew letter aleph. And this is a number. And you can use it in equations. You can do operations on it. You can add to it, and you can add it. You can multiply it. You can even exponentiate it. You can have aleph to the second power and aleph to the third power. And it's useful in set theory. Aleph is used to enumerate the number of elements in an infinite set. And let me show you a few examples of what those infinite sets look like. Our first one looks like this. 1, 2, 3, 4, so on and so forth. This set of numbers is the set of all natural numbers. And wrap your brain around this. This set actually contains all of the natural numbers. So how many numbers are in this set? Infinity. There are an infinity of numbers in this set. Okay? Let me show you another set. 1, 3, 5, 7, so on and so forth. This would be the set of all odd natural numbers. And this set actually contains all of the odd natural numbers. How many numbers are in this set? Infinity. That is correct. Now, how many people, when I asked that question, thought that there was half of infinity in there? Right? Because it only includes all the odd numbers, where there's no even numbers. And so you would think that this first set has twice as many numbers as this set. But it doesn't. They have exactly the same. Infinity. One more example. 4, 5, 6, 7, so on and so forth. This would be the set of the natural numbers greater than 3. It's the natural numbers starting with number 4. How many numbers are in this set? Infinity, that is correct. And again, how many people thought that there was infinity minus 3 numbers in there? Yeah, you would think. And if there, well, we'll get to that. You would think, but actually no, they have the same number of elements. All 3 of these sets have the same number of elements. So, if an actual infinity exists in mathematics, doesn't that mean that it could exist in the real world? Well, the answer is no. Because what works in mathematics results in all sorts of absurdities in the real world. And the best way to show these absurdities is by use of an illustration. And this is probably my all-time favorite illustration. It's called Hilbert's Hotel. And it is the brainchild of the German mathematician David Hilbert. So first, we need to imagine an ordinary hotel. Let's say that it has 100 rooms in it. And all 100 rooms of that hotel are full. When a new guest comes up to the counter looking for a room, what does the hotel manager tell him? sorry, we're full. You're going to have to find somewhere else. And the guest leaves. That's the end of the story. But now, let me invite you to imagine a hotel with an actually infinite number of rooms. And once again, the hotel is completely full. There is an actually infinite number of guests checked into that actually infinite number of rooms. Now what happens when a new guest comes to the front desk in order to check in? Does the hotel manager say, sorry, we're full, and turn them away? Not at all. No problem, says the hotel manager. What he does is he takes the guest in room number 1 and moves into room number 2. The guest in room number 2 and into room number 3. The guest in room number 3 moves into room number 4, and on and on and on to infinity. As a result of this operation, room number 1 becomes vacant, and the new guest gratefully checks in. But now, at this point, there are the same number of guests in the hotel as there were before the new guest arrived. Infinity. So infinity plus 1 is infinity. That's how it works in set theory. Now let's imagine that an actually infinite number of new guests arrive at the front counter in order to check in. It's a very busy hotel. Now you would think that now there's no way that the hotel manager can accommodate an actually infinite number of new guests. But you would be wrong, because what he does is he takes the guest in room number 1 and he puts him in room number 2. He takes the guest in room number 2 and puts him in room number 4. And he takes the guest in room number 3 and puts him in room number 6. Each time, putting the guest in the room number double his own room number. And because every number multiplied by 2 is an even number, this leaves all the odd-numbered rooms vacant. And as we already saw, all of the odd numbers is an actual infinity. And so the infinity of new guests is accommodated into the hotel and gratefully check in. And once again, the number of guests in the hotel is exactly the same as it was before the guests arrive. Infinity. So in this case, infinity plus infinity is still infinity. It gets worse. Now imagine that the guests want to check out. Let's say all those guests that were in the odd-numbered rooms decide they're done with their stay, and they check out. In this case, now you have an infinity of guests that have left the hotel, and an infinity of guests that still remain. Infinity minus infinity is still infinity. Now, the hotel manager doesn't like having a half-empty hotel. It looks bad for business. And so what he does is he reverses the last operation in order to convert his half-empty hotel into a hotel that's bursting at the seams. And you would think that the hotel manager could keep his strange hotel always completely full by use of these operations. But again, you'd be wrong. Because now let's imagine that the guests in rooms 4, 5, 6, and 7, so on and so forth, check out of the hotel. Now how many guests are left in the hotel? 3. 3 is correct. The guests in rooms number 1, 2, and 3. Now the hotel only has 3 people in it, and there's nothing that the manager can do to make his hotel look full anymore. Could Hilbert's Hotel exist in reality? No. We can tell by use of these examples that this is absurd. There couldn't actually be an infinite hotel that could accommodate an infinite number of guests. And in fact, these last 2 operations that we did show that there is a logical contradiction between actual infinity. In this case, we did infinity minus infinity and got infinity. In this case, we did infinity minus infinity and got 3. And this is logically contradictory. We subtracted identical quantities from identical quantities and got non-identical results. And it's for that reason that within set theory, it is prohibited to subtract from infinity, or to subtract infinity. It's against the rules. And this isn't like dividing by 0. You can't divide by 0 because dividing by 0 is meaningless. For example, what does it mean to take 10 jelly beans and put them in 0 groups? That doesn't make any sense. In this case, subtracting infinity isn't meaningless. It has meaning, but it's against the rules. It's against the rules because these absurdities result. It's arbitrarily prohibited. You're not allowed to do it. But even though we can slap the hand of the mathematician who tries to break the rules, could we stop an actual infinity of guests from checking out of a hotel? No. If you try to bar the doors, they'll jump out the windows. So all of this goes to show that the actual infinity that's used in mathematics is really just saying, let's pretend. Let's pretend that there could be an actually infinite number of things, and then we can use that in order to solve certain problems that are way over my head. But it doesn't translate into the real world. So even though there's an actual infinity in mathematics, you can't have an actual infinity in reality. Any questions on this first line of evidence? There can't be an actually infinite number of things. All right. Then let's go ahead and move on to our second line of evidence, our second line of philosophical evidence. You cannot pass through an infinite number of things one at a time. You cannot pass through an infinite number of things one at a time. The series of past events has been formed by adding one event after another. And so the series of past events is like a sequence of dominoes falling one after another until the last domino, today, is reached, right? When the last domino falls, we've reached today. But no series that is formed by adding one member after another can be actually infinite, for you cannot pass through an infinite number of elements one at a time. And this is easy to see in the case of trying to count to infinity. No matter how high you count, there's still an actual infinity of numbers left to count. But if you can't count to infinity, how could you count down from infinity? This would be like trying to count down all of the negative numbers ending in 0. -3, -2, -1, 0. Made it. But this seems crazy, for before you could count 0, you'd have to count -1. And before you could count -1, you'd have to count -2. Before you could count -2, you'd have to count -3. Back and back and back and back. You just get driven further and further back into the past. This is like trying to jump out of a bottomless pit. There's no ground for which your feet to get purchased to begin your upward momentum. So if there could be an actually infinite number of past days, which we just established that there couldn't be, but let's say for a second that there could be. If there were an actually infinite number of past days, we could never reach today. Because there's no starting place for those dominoes to start falling, that last domino would never fall. And so if the events in the past were actually infinite, you'd have no starting point in order to get to today. But have we made it to today? Yeah, here we are. Because we've reached today, that means the events in the past could not be actually infinite. The series of past events must have had a beginning point. Any question on this line of evidence? The difference between these two lines of evidence is the first line of evidence shows that there could not be an actually infinite number of things. The second line of evidence says that even if there could be an actually infinite number of things, if those things were in sequence, you could never get through that sequence one at a time. All right, let's go ahead and move on to our third line of evidence and our first scientific line of evidence. And this line of evidence comes from the thermodynamics of the universe. The thermodynamics of the universe. This is a concept that we already talked about in this class. It comes from the second law of thermodynamics, which is the law of increasing entropy. And that word entropy just means disorder. And the second law states that unless energy is being fed into a system, that system will become increasingly disorderly. It's the law of increasing entropy. So for example, if we took a gas jar and we injected a small amount of gas into the glass jar, those gas molecules are not going to huddle in one corner of the jar in an orderly fashion. It's going to spread itself out throughout the jar until it reaches equilibrium. Equilibrium being the state in which the entire area has the same temperature and pressure. And that's because there's many more ways in which the molecules can arrange themselves randomly and disorderly than there are ways that they could arrange themselves orderly. And this is intuitive. We all know that this is how the universe works. What happens when you apply the second law to the universe as a whole? Already in the 19th century, scientists realized that the second law implied a grim prediction for the future of the universe. Because the universe is a closed system, just like that glass jar, there is no energy being fed into the universe. So given enough time, all of the molecules in the universe will spread out evenly until the universe reaches equilibrium. This will be the state in which temperature and pressure will be the same everywhere. The universe will be nothing more than a thin gas of subatomic particles in which no life is possible and no significant further change is possible. Does anybody remember what we call this state of the universe? Gabby? David? Heat death is correct. You were close, Gabby. Yeah, this is the heat death in a universe. Given enough time, the universe will stagnate in a state of heat death. You can think of it like an hourglass. When you flip over an hourglass, you got sand in the top that's gradually going into the bottom. Given enough time, all of the sand in that hourglass is going to be in the bottom. But if that hourglass had been running for an infinite amount of past time, shouldn't all the sand be in the bottom of the hourglass? In the same way, if our universe will eventually stagnate in heat death, if it were infinite in the past, shouldn't it already be in a state of heat death? But is the universe in a state of heat death? No, it's not. It's still got time on the clock. So all of this goes to show that the amount of past time could not be infinite. In a finite amount of time, the universe will stagnate in heat death, and it hasn't yet. So that means there couldn't be an infinite amount of past time. Otherwise, we'd have been in the heat death of the universe already, and we wouldn't be here. Any questions on this line of evidence? Yes, Mason?
What about if people were on Mars, if that ever became possible? Would
Yeah.
that happen, the same thing?
Great question. So Mason asks, what if people were able to be on Mars? Wouldn't that avoid the heat death of the universe? And the answer is no. Not only will the Earth, but all of the planets and the sun will eventually end up as a thin gas of subatomic particles. And not just the sun, but all of the stars in the Milky Way galaxy. And not just the Milky Way galaxy, but the entire galaxy cluster. And every galaxy cluster in the universe will eventually be nothing but a thin gas of subatomic particles. There is no escaping the heat death of the universe. Jeannie?
Okay, I'm make sure I'm understanding this correctly.
Mm-hmm.
So because infinity can't be counted one thing at a time, if you're going to talk about infinity, then you're talking about the whole thing.
Yeah.
So
Mm-hmm.
that's why if it was infinite, it's already over. Is that correct?
Yeah. Given enough time, our universe will stagnate in heat death. And if there were an infinite amount of past time, it should already be in a state of heat death, right? But it's not. Here we are. Anybody else? Yes, David?
But could this be the containment, like where it would be the equalization?
Oh, could the universe already be in equilibrium? No, the universe is still highly ordered at this point. There are subatomic particles that are formed into molecules. There's molecules that are formed into all the stuff that we see and know today. The state of equilibrium is going to be nothing but a thin gas of subatomic particles that don't make up anything else. Yes, Ed?
If this helps at all, the same concept can be expressed as the quality of available energy,
Mm-hmm.
whereas low entropy or high entropy means there's no available
No.
energy to do anything.
Yeah, very good. That's right. Josiah?
Can we at least talk or mention the Big Crunch oscillation?
Yeah.
And also Canton's theory of multiple sizes of infinite?
Yeah, absolutely. So there have been attempts by atheists in order to avoid the beginning of the universe on the basis of the second law of thermodynamics. And some of those attempts include Boltzmann's many worlds hypothesis, oscillating universes, baby universes. And all of these attempts to avoid the beginning of the universe have either resulted in models that don't avoid the beginning of the universe, or they prove to be unworkable. People have tried to propose models of the universe in which the universe does not have a beginning, and they've all failed to avoid the beginning of the universe. They either don't work, or they still end up having a beginning. So there have been attempts. The atheist's last line of hope lies in the possibility of the multiverse. And we're going to talk about the flaws of the multiverse when we discuss the teleological argument. Yes, Gabby? Mm-hmm. Yeah. Sure. So not quite, but Gabby was just bringing up that another example of something reaching equilibrium is if you were to spill water on the floor. That water doesn't just huddle in the shape of a glass jar, right? It spreads out as far as it can spread out, and it will eventually all reach the same temperature, the temperature of the room, right? Good. Yes, Steve?
One of the things you see on TV and kids shows and even adult shows is the multiverse.
Mm-hmm.
It's gaining momentum.
Yes, sir.
And you see that as really from Satan. That's people trying to
Yeah.
get our kids to think, oh, yeah, multiverse.
Yeah, I agree. And when we do the next lesson, the teleological argument or the design argument, we'll see why the multiverse isn't possible. You'll have to hold on to that. All right, I am running a little short on time. Oops, I forgot to advance the slide a few times, guys. I will give you a second to fill out your worksheets here before I move on to the next law. Let's see, I've got 15 minutes. Yeah, we've got enough time to do our last line of evidence. All right, if you still need the rest, come see me after class because I got to keep moving. The last line of evidence, the second line of scientific evidence, comes from the expansion of the universe. The expansion of the universe. In 1915, Albert Einstein published a new theory of gravitation called general relativity. See, we had an old theory of how things fall. Back in the 1600s, Isaac Newton gave us a theory of gravity that described how things fall on Earth. But as our telescopes got better, we noticed that celestial bodies, things like planets and stars, they move a little bit differently than things do on Earth. And so we needed a new theory of gravity. And Albert Einstein was the man for the job. He came up with a new theory of gravity called general relativity. As Einstein figured out this new theory of gravity, the results troubled him because his calculations described a universe that was blowing up like a balloon. And this was troubling for Albert Einstein because he didn't want the universe to be expanding. Albert Einstein held to a sort of pantheism, and he thought that the universe was static and unchanging. And so what he did is he looked back at his calculations and he says there must be some force out there that's keeping the universe from expanding. And he went into his equations and he inserted what is called the cosmological constant. When he inserted the cosmological constant, now his model, his calculations described a universe that was static, just the way that he liked it. That cosmological constant that he inserted was nothing more than a fudge factor that Albert Einstein inserted into the equation in order to satisfy his philosophical predispositions. During the 1920s, Russian mathematician Alexander Friedmann and Belgian astronomer Georges Lemaitre decided to take Einstein's original equation at face value and independently came up with models of the universe that were expanding. And these models worked really well. And then in 1929, through tireless observations on Mount Wilson Observatory, Edwin Hubble made a startling discovery which verified Friedman and Lemaitre's models. He saw that the light coming from distant galaxies was redder than expected. Now, don't ask me how he knew how red those galaxies were supposed to look. I don't know. But they were redder than he expected them to be. And the only plausible explanation for this red shift is that as the galaxies that he was looking at were moving away from us, the light waves were being stretched out as they expanded away from us. And it didn't matter where in the sky he trained his telescope, this red shift was constant. And so it looked like to Hubble that our planet, our solar system, was in the middle of a cosmic explosion with every other galaxy in the universe flying away from us with tremendous speeds. But we didn't have this misconception for long because we had Friedman and Lemaitre's model at first. And according to Friedman and Lemaitre's model, the galaxies are actually at rest in respect to space, and space itself is expanding. As space itself expands, the galaxies recede away from each other. And a good illustration would be to think of a balloon that has buttons glued to the surface of the balloon. The buttons don't move across the surface of the balloon, they're stuck. But as you blow up the balloon, all of the buttons recede away from each other. And it doesn't matter which button's perspective you look from, it looks like all of the other buttons are expanding away from it. And so the same thing holds true for the galaxies in the universe. An observer on any galaxy would see all other galaxies flying away from him through space. So that's how the expansion of the universe works. Any questions on the idea that our universe is expanding and how that works? Yes, Mason?
How come multiple people would see it from far away? Like, if you were in a different galaxy, how come you see the other galaxies so far away? Even though when you look, it looks closer to this galaxy than to your galaxy to that.
Yeah, well, the point is, no matter which galaxy you're on, it's going to look like every other galaxy is going away from you. Just like those buttons on the balloons. As the balloon gets blown up, all of the other buttons recede away from each individual button. Yes, Gabby? You can't. You cannot get to another galaxy. But it's what it would look like if you were on another galaxy. Yes?
Aren't there some coming at us, though?
Yeah, so there are some galaxies that are close enough to us that within their movement in the galaxy cluster, they're actually moving closer. And so that would be an example of a galaxy with blue shift. But by and large, nearly every galaxy that we can train our telescope on is moving away from us. David?
So wouldn't that then support the Big Bang Theory that atheists are?
Yeah, great question. So the question is, how does the expansion of the universe, how is the expansion of the universe evidence for the beginning of the universe? And the answer is, when you trace the expansion of the universe backwards through time, you eventually reach a state in which the distance between any 2 points in space is 0. So on this model right here, the horizontal axis is time, the vertical axis is space. As you go forward in time, space gets bigger. But if you trace the expansion of the universe backwards, you'll reach a point in which the distance between any 2 objects in the universe is 0. And this is the beginning of all time, space, and matter. Now, what does what I just described sound like? You can say it. It sounds like Genesis. That's a great answer. Anybody else? David said it just a second ago. What is it? What is this?
Big Bang.
That's the Big Bang, yeah. The reason it sounds like the Big Bang is because that is the Big Bang. See, Friedman and Lemaitre's model eventually became known as the Big Bang Theory. And I know that the Big Bang Theory has a really bad rap among Christians. And I think that that's unfortunate, because I think the Big Bang Theory is some of the best evidence that we have for the beginning of the universe, and so for a creator. And so I'm really hoping that you guys will hear me out for the next couple of minutes. I think the universe, or the Big Bang Theory, gets a bad rap for two reasons. Number one is the misconception that the Big Bang Theory describes how the universe came into existence out of nothing. And the second reason is that the timeline given in this model contradicts the timeline in Genesis. As respects to the first objection, we already talked about this in one of our previous classes. We saw that the Big Bang model is not a model of how the universe came into existence out of nothing. Rather, it's just a model of the expansion of an already existing universe. In fact, the Big Bang model doesn't include the first few moments after the Big Bang, because we don't have a working model of what the universe would have been like when it's smaller than a subatomic particle. So that is a big question mark. That area right there is still reserved for creation. And in respects to the second objection, I agree that the timeline in the Big Bang Theory contradicts the timeline in Genesis. And because of my commitment to the literal interpretation of Genesis, I think the timeline of the Big Bang Theory is wrong. I think that the timeline given in Genesis is correct. But that is really the only problem with the Big Bang Theory. I think the Big Bang Theory is actually a really good step in the right direction. I think the Big Bang Theory is what happened immediately after Genesis 1:1. Genesis 1:1, God created the heavens and the earth, and boom, all of space, time, and matter came into existence. And then God begins arranging all of that matter into the things that we read on the days of creation. He arranges that matter into light. He arranges it into sky and seas. He arranges it into plants. He arranges it into stars and the sun and the moon. So even though I think they got the timeline wrong in the Big Bang Theory, I think this is some of the best evidence that we have for the beginning of the universe. And in fact, atheists hate that the Big Bang Theory describes a beginning of the universe because they see the theological implications. Is that a hand, Bob? Yes.
When you started the class, you said something to the effect that Dr. Craig didn't believe in biblical, I forget how exactly.
The literal interpretation of Genesis 1 through 11.
Right. Does he believe in the Big Bang?
He does, yes. And my beliefs about the Big Bang are not the same as Dr. Craig's. Dr. Craig would accept the full 13.7 billion year timeline of the Big Bang Theory, and I'm saying that's wrong. It contradicts what we read in Genesis 1, and I have a conviction to the literal interpretation of Genesis 1. So I think that this is wrong. But it's a step in the right direction. And atheists hate the fact that the Big Bang Theory predicts a beginning of the universe. The history of the 21st century of cosmology can be seen as a series of one failed attempt after another to avoid the prediction of a beginning of the universe as predicted by the Big Bang Theory. They have proposed model after model after model, trying to get this one to stop being the standard model so that they can get a model that doesn't have a beginning. And they failed to do so. They've either, every model that's been proposed either fails to avoid the beginning of the universe, or it shows to be unworkable. And something of a watershed appears to have been reached in 2003 with the advent of the Born-Guth-Vilenkin theory. And the Born-Guth-Vilenkin theorem proves that any universe that has, on average, been expanding throughout its history cannot be infinite in the past, but must have a space-time boundary. The Born-Guth-Vilenkin theorem proves that there cannot be a successful model of our universe that fails to avoid the beginning. I'd like to read a quote by a guy named J.M. Wersinger. This is a quote that's found in On Guard. J.M. Wersinger is a professor of physics at Auburn University. He says that at first, the scientific community was very reluctant to accept the idea of a birth of the universe. Not only did the Big Bang model seem to give in to the Judeo-Christian idea of a beginning of the world, but it also seemed to have to call for an act of supernatural creation. Atheists hate the Big Bang theory. It took time, observational evidence, and careful verification of predictions made by the Big Bang model to convince the scientific community to accept the idea of a cosmic genesis. The Big Bang is a very successful model that imposed itself on a reluctant scientific community. Now, I realize that the Big Bang Theory is still going to make a lot of people uncomfortable. And if you wish to reject this fourth line of evidence for the beginning of the universe, I don't blame you a bit. Go ahead and feel free to throw it out. We still have 3 really good ones, each of which can support the truth of premise 2. But my hope is that you've just begun to see that maybe we shouldn't throw the baby out with the bathwater. It seems like Christians saw this 13.7 billion year timeline and said, that's wrong, and they just rejected this carte blanche, when in fact it's that timeline that's the only problem. And the Big Bang Theory predicts creation. It predicts Genesis 1:1. I am out of time. I know this is a point in which there could probably be a lot of discussion, but we are out of time. I'm going to have to wrap this up, but feel free to come talk to me after class, and we can discuss this if you like. Let's go ahead and wrap this up. The cosmological argument is a logically valid argument. So if the premises are true, the conclusion is necessarily true. Premise 1, that everything that begins to exist has a cause, is virtually certain and is undeniable by any sincere seeker of truth. Premise 2, the beginning of the universe has 4 independent lines of evidence, each of which could support the truth of premise 2. And so premise 2 is true to a very high degree of certainty. And because premise 1 is certain and premise 2 is true to a very high degree of certainty, that means the conclusion is true to a very high degree of certainty. The universe has a cause. We saw that when we looked at the cause of the universe, we knew that it must be an immaterial, spaceless, timeless, unimaginably powerful, and personal creator of the universe. So on the basis of the cosmological argument, I think it's true that the universe had a beginning. And that beginning must have been caused by God, and that God must exist. Please open up your songbooks to song number 500. Logan is going to lead us in O Thou Fount of Every Blessing in just a moment. We talked about how it's impossible for there to be an infinite amount of past time. But what about our future? The amount of time in our future is potentially infinite. When we die, our life is going to go on, and it's going to go on and on and on and on for a potentially infinite number of days. And the question is, where are you going to spend those days? Are you in a right relationship with God? Are you going to spend those days with Him? Or are you not? And are you going to spend those days separated from God? If that's your fate, I invite you to come forward now, be baptized into the name of Jesus Christ, and become a follower of God as we stand and sing.